hypothesis is the statement with the equal sign. The alternative hypothesis is the other one. All right, so the null is the statement that involves the equal sign. The alternative is the other one. And it'll have a greater than, or a less than, or not equal. It is possible. You see the notation. Depending on the actual question asked, the second sentence above may not be necessary. All right, because sometimes the question's only asking about the null, in which case you're answering a question that's not even being asked. If you put both sentences in, though, you can never be wrong as long as you write them correctly. It's just I'll look at your second sentence and be like, okay, cool, didn't need to know that. Be like, all right, hey, are you going to wear that Superman t-shirt tomorrow? Yeah, I'm going to wear that Superman t-shirt and the Batman shorts. They're like, cool, I didn't care about your shorts, but yeah, like, thanks. Like, that's awesome. You know? So, anyway. Complete graphing calculator approach. Hypothesis tests can be found in the stat test menu. Stat. So the same stat key that you would hit to go to stat calc, stat edit to put data in, but then you'd hit the right arrow twice, which is going to bring you to the test menu. All right. All of these hypothesis tests will be found in this menu. It's just a question of finding the one that you need. All right. So I think this one might be stat TED 8. Ted, that's my name. Stat test 8, but I can't remember off the top of my head. Unless, of course, I did remember off the top of my head, but I don't think I did. Actually, I can just keep going. Fuji? Yeah, I'm throwing things at me here. I don't even know. Because there was one like Jonah Hills or whatever they're called. Jonah Max? That's another one. I know the Max stood for. I can't remember what the Jonah for. Jonathan something or other. I don't know. One Apple thing. What the hell? They're like making stuff up now. Apparently they are. They're just making more and more hybrids of apples. It's like, this is great. But I don't know. Like more into strawberries now, though. But I feel like strawberry is more of a versatile fruit. You do a lot more with it, I think. You know, you could pop it into a salad. You could put apples in a salad too. But I don't know. Something just doesn't feel right about dipping your apple in chocolate. But strawberries, you could do that. I mean, you could do it in any kind of chocolate. You could go dark chocolate, white chocolate. Very, very versatile.
Strawberry is like almond butter, you know? It's an apple stuff.
Yeah, that's true. That's true. Maybe it's more of the earthy sorts of spreads. All right, so it is claimed by someone at some point that apples are the most delicious fruit on the planet. That's just and it's already a flawed statement because I just kind of elaborated on it, where it's like, well, now you get into different kinds of apples. If I told you that your only choice was Granny Smith apples versus strawberries, then you might be like strawberries. But then I go to somebody else and I say, okay, Macintosh against strawberries, and you're like, okay, well, the Macs, definitely, you know. So a lot of different ways to vary this. Test this claim let us determine if the majority of the population responds apples when asked what they think the most delicious fruit is. A sample of 4,500 people are randomly selected and polled. It is determined that 2,475 people chose apples as the most delicious fruit. Using a 0.05 significance level, test the claim that the majority of the population finds apples to be the most delicious fruit. All right. So what we're doing here is we're testing a claim about a percentage. Now, when you're dealing with a population, well, the easy thing to say is the word population should be in there somewhere. but we call it a population proportion. All right, so that percentage is really a global percentage. And I don't mean global as in like on the planet specific, even though they use the word planet in the question, whoever they are. It's really saying all of a particular category. Right? So if I were talking about a global percentage here at the college, I'd be talking about all of the individuals at the college. It's implying population. All right. So anytime that's happening, you're dealing with population proportion. So if you're doing a project, you want to be thinking, all right, am I collecting data related to counts? Like the number of people falling into a particular category. If that's the case, then you might be doing a population proportion test. All right. Now, if you're collecting information like, the average time it took a person to cross the street, right, or the person's blood pressure or something like that, that wouldn't be a proportion because it's not a percentage. Those are actually raw data, and you're going to find averages related to that. That's a different concept, which we'll get to in a little bit. But if your information was, what was the one I sent out? It's like people who look both ways when they cross the street, something along those lines. Like that would be a count, right? All you're doing is counting up the number of people who look both ways, counting up the number of people who blow the stop sign, right? Counting up the number of people who are looking at their phones while they're waiting at a stoplight. Whatever your topic is, that would fall into a category very similar to this. May even be exactly this category, right? And in fact, if you can look at this problem and say, okay, well, if I replace the word apples with iPhones, will this be the same thing? Actually, it doesn't. You don't even have to replace it, right? It's the same thing. Then you might even have the same question, right? So if that's the case, then I might be doing your statistical analysis for you right now. All right. So we have 4,500 people. That's an N value. Number of people in a population, sample, whatever, some variation of the letter N. It's just if it's the number of people in a population, we go with a capital N. But we don't know the number of people in a population. That's why we're looking at a sample. Right? If we knew how many people were in the population and we could actually access all those folks, then I would just ask them, oh, you like apples? Yeah? All right. Oh, put Charlie down for apples. Joe, apples? No? Okay, Joe doesn't like apples. And just go down the list, But when the population gets too large, then you go with this approach. This is the connection. X would be the number of individuals who selected apples. So this is the number of successes, like binomial probability. If we can assume that these 4,500 people are representative of the population, in these word problems, we assume that. We assume that the sample was collected using randomization, that there were no bias incorporated into their selection. I didn't only select people who had like Apple-related T-shirts. Like, oh yeah, you should be in my sample. I think it'll help make it completely unbiased. It's not really like that. It's completely academic, where you're looking at it and saying, all right, there's no reason for us to think that there's any ulterior motive associated with this. All right, our alpha value is 0.05. I can go to a different color on that. All right, so what we need to do is test the claim that the majority of the population likes apples. I'll just say it like that. All right, majority. Mathematically, by definition, it's a percent that's greater than 50. Minority would be a percent less than 50. If you're in the majority, you're more than half. If you're in the minority, you're less than half. Right? So we need to manufacture a null and alternative hypothesis out of this. All right? So what I'm saying here is that I'm looking for a majority. I need my percent, my population proportion, which we call P, to be greater than 50, but we use actual decimals instead of percents. So P has to be more than 0.5. Now, that would be an alternative hypothesis. That's an HA. You don't have to state your HO before you state your HA. You can state it in whatever order you want. We're just pulling information out of the problem. I know it's an HA because it doesn't have an equal sign. The only type of hypothesis that has an equal sign is the null hypothesis. All right? So you look at it and say, okay, well, where am I getting the null hypothesis? Well, my null, my HO, is going to be made up of the same exact ingredients as the alternative. So it's going to have a P, it's going to have a 0.5, but it will also have an equal sign. And the rationale behind this is, if I'm not strong enough to move the wall, I'm just going to leave the wall where it is, all right, at 0.5. The reason why is because, yeah, okay, maybe it's not a majority, but then I can't turn around and say it's a minority, right? If I were to say, okay, my claim is apples are the most delicious fruit on the planet. Okay, that was wrong. Therefore, apples are the least delicious fruit on the planet. Well, I don't think I proved that either. Right? All I was doing was looking to see if it was the most delicious fruit. If it's not, I don't really know anything about it other than to say maybe people are indifferent to it. Or it's as delicious as everything else. Okay? So I don't have enough evidence to go in the opposite direction, so I just leave it as is, leave it at the 0.5. All right? And that's the case for every hypothesis test. Whatever your alternative is, your null is going to be made up of the same ingredients, just with an equal sign instead of the inequality. The good news is the calculator only needs the alternative hypothesis. All right? We don't need the null. All right? So, and I'll show you what that looks like in a second. All right? So this information, statement of summary statistics, null and alternative hypothesis, we need our alpha value, that's the important thing. And then calculator, we do stat, test. It was option 5. I think option 8 is one of the confidence intervals. All right, so you come up with this menu here. Let me just snip it in so I can talk about it a little bit. So we'll have to adjust the entries here. So this is going to be the value in your null or alternative hypothesis, because again, it's the same number. So it really, like I said, it really doesn't matter what you have in your null, because it's the alternative that makes the difference, because you're going to have the same number no matter what. Your x, well, hopefully that's obvious. X is x. Number of successes, though. Just be careful about context, because I think it was on the last test where there is like defective items. Maybe it was on the review, I'm not really sure, but somewhere along the lines we talked about defective items, but that was considered success in the context, because that's what we were looking for. Like in a life insurance policy, success would be the person dying. So you don't necessarily consider that in real life a success, but it would fall under the category statistically of a success, which is why the people who do insurance are so miserable. N is the number of trials, but really, do we consider a person a trial all the time? Not necessarily, but that's what it's called. Yeah. You're a trial. Every time you fill out a survey, you're a trial. It's kind of depressing. Prop less, not equal, less than, or greater than. That corresponds with your alternative hypothesis. So this is the one that we want. This corresponds with HA. So this is inequality used in HA. And then we go to calculate. Draw is a nice option if you needed to actually see the normal curve and the actual proportion of the normal curve that's accounted for by this situation. It'll tell you just how much of it is actually shaded, kind of like a central limit theorem and normal distributions and stuff. Right? Because only a certain part of it should be shaded. If more of it's shaded, it tells you something. But calculate is really all we need. All right. So let me put these numbers in. Hit enter on calculate, and we'll see where we're at. So 0.5. Enter. 2475. All right. The problem almost always will give you the n value first, then the x, but the calculator always wants the x first, then the n. Number one cause of error here is people putting it in backwards, getting an error message, and wondering why. Well, if you have only 2475, so 2,475 people, how can you have 4,500 successes if you're only asking them the question once? You know, so go down to calculate and hit enter. I'm just going to snip this in before I do that. I hit the wrong thing. Copy. Now paste. There we are. Calculate. And then we get this. A lot of information. Some information we need. Most we don't. Some we already knew. Prop greater than 0.5. Well, we knew that. Here's the 0.5. Here's where we put the greater in. The 0.55, that's just x divided by n. So we already knew that. I mean, we didn't figure it out. That's 2475 divided by 4,500. N, we told it n, so I don't know why it's telling us it back. What we need from this is just this particular p-value, which is, I don't know, it's kind of weird because we're looking for a p-value, but it seems like everything was p. Like we have p's all over the place. So what p-value are you speaking of? This p-value here, the one below the z statistic, and that's a z-score, by the way. And there's an explanation behind that we'll talk about a little bit. But the p-value, I mean, in decimal form, without the scientific notation, this would be 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 9, 9, 1. So 11 zeros followed by a 9, 9, 1. That's what that equates to. Okay? But most people are fine just looking at this and saying, all right, e negative 12, really, really, really small. Like very close to 0. You don't actually have to write out this number for it. You could write it just as you see it here. Just write it all the way, especially if you see the e. Write it all the way through the e, including the negative 12 at the end. All right. The reason why is because if you look at that and you just write 9.906, you're telling me that a probability value is 9.906. That's terrible. That means two things. And one of them is more egregious than the other. Well, one is that you don't really have a sense of scientific notation. That part, that can happen. The more egregious one is you don't have a sense of probability. And that's kind of a problem when more than half the course is probability. if you don't know that probabilities can only exist between 0 and 1, that was like day one material in the probability unit. That is like most people, they didn't understand, like if you didn't understand binomial probability, central limit theorem, all this other weird stuff, like all that was hard. But most people walked away being like, okay, well I know it's got to be between 0 and 1. Everything else after that is a crapshoot. But I do know it has to be between 0 and 1. Alright, if you write this 9.906, you're telling me that a probability can be equal to 9.906? That's not between 0 and 1. I mean, that was question 1 on the last test. What are the restrictions of a probability? Has to be between 0 and 1. Alright, so give me the entire decimal. Now, in terms of the interpretation, we compare the p-value and the alpha value. If, and this is stated previously, but I'll write it again. If the p-value is less than the alpha value, we reject the null hypothesis. All right? So the p-value, I mean, you don't even have to write them in order to know, but I'll write it anyway. So we have 9.906446 e negative 12. And we want to know, is that less than 0.05? I think it was 0.05. Yeah. Damn right it is. This is practically 0. This is a smidge more than 0. That's definitely less than 0.05. All right? If I were plotting this on a number line, I don't even think I could physically place 9.906 times 10 to the negative 12th power. 0.05, I could kind of estimate it. I mean, I have to go 1/20th of the distance between 0 and 1. But to go 0.00, you know, all of it, 991, I mean, like to actually plot a point would be overestimating where it would be. All right? So this is true. It is less. So yes, therefore, reject HO. So the null hypothesis is out. It's false. Now we just have to state our conclusion. All right? And bear in mind, I mean, this is like, look at all this writing I'm doing here. This is not much writing because I'm giving you notes here. Oh, this is happening on your calculator. This is happening on your calculator. You think about what's happening here. You'd write down on a test, you write down n and x. Alpha is already given. You can make a note of it if you want. You give me HO, HA, jump right to the p-value, tell me whether it causes a rejection, and then write your conclusion. So almost none of this stuff here is going to be written. All right? So it seems like a lot, but it's not. All right? Okay, so we are rejecting the null hypothesis, which means that the HO is bad, the HA is good. So we just have to write our conclusion. Let me grab the template from the previous page so I can modify it. Or at least just refer to it as I'm scribbling. Aw, undo. I'll just paste that here. So you look at the template. The only things that are changing would be this, 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 and this. Well, and a statement of true or false. So seems like a lot, but it's not. That's the recurring theme. Seems like a lot, but it's not. There is. Well, we're talking about rejecting the null. So I'm asking, is there enough evidence to reject the null? Well, yes, I'm rejecting the null, so yes, there is. There is sufficient evidence to reject the claim Now, this was a big source of a misconception in the past, and I've tried the best I could over the years to try to guide people the right way. But no matter how many ways I've said it, there's always folks who slip through the cracks. I say state the null hypothesis in words. You know, the people who just take things too literally, and they will say, okay, well, here's my null hypothesis, p equals 0.5. So that's my null hypothesis, p equals 0.5. They will actually write p equals 0.5. That is not what I mean by stating it in words. What I mean is in the context of the problem. All right, so what does p equal 0.5 mean in this particular situation? So P stands for population proportion. At the population proportion of, and you could simplify things, you could paraphrase. I mean, because I don't expect people to write, what is it? Population proportion of people who find apples to be the most delicious fruit. That's a lot. Of people who like apples. So that population proportion, that is your P, right? You don't have to designate it as P in the write-up. I'm just doing that for note-taking purposes. So the population proportion of people who like apples is 0.5. You could say 50% if you want. All right, that's what my null hypothesis is stating. At the 0.05 significance level. Therefore, the claim that and this is where we state the alternative hypothesis in words. The alternative hypothesis was that P was more than 0.5. That you have some wiggle room on, because P more than 0.5, we got that from the fact that we were talking about a majority. All right, so that was kind of the symbolic representation of a majority. So therefore, the claim that a majority of the population, that means the same thing. That would be fine. You could also write, therefore, the claim that the population proportion of people who like apples is more than 0.5. I can accept that also. But a majority of the population is a little simpler. All right, this is where folks kind of lose sight of something that's actually pretty simple. Because it's asking you if it's true or false. That a majority of the population likes apples. Either true or false. Well, going back to my null and alternative hypothesis, once I decided that I'm rejecting the null, that made that false. The null is false. Once I put that check mark next to the alternative, that made that true. The second sentence in my conclusion is addressing the alternative hypothesis. The alternative has a check mark next to it, and I just said that it's true, so therefore, true. Now, I mean, people have just memorized before. They like, I don't know. whatever works for you. I mean, are you going to go home on a daily basis and write conclusion statements for hypothesis tests? Yeah, most likely. Somebody said, hey, listen, I've noticed that every time I write the word sufficient, it's also true. Can I just do that? I'm like, well, it seems that you've noticed that every time that's the case, so I don't know why you're asking permission. I'm like, yeah, if that's the case, then yeah, by all means. If that's a relationship that you notice is true, then go for it. The one thing is, sometimes that second sentence is not always necessary, but like I said before, even if it's not necessary and you write it, if it's correct, it's fine. The only drawback to something like that would be the idea that if you include something and it's incorrect, you're on the hook for it. All right? So if it wasn't necessary to begin with, you put it in and there's something wrong with it, you're going to lose some credit. All right? And you're not going to be happy about it. At first, you're not going to be happy about it in my direction. Then eventually you'll be not happy about it in your own direction, you know. So, but that doesn't always happen as quickly as I would like. It's like, well, I didn't tell you to write it, so I don't know why you wrote it. But you wrote it, so I had to grade it. So don't write